this video, I'm going to show you guys a technique you can use to derive each of the 6 inverse trig function derivatives, so you don't need to memorize them. The example that I'm going to be using is y equals inverse sine of x, but this can also be used for inverse cosine of x or inverse tangent of x, or really any of the 6. So y equals arc sine of x can also be rewritten as x equals sine of y. We're going to take the derivative of this implicitly with respect to x, so 1 equals cosine of y times y prime. Isolating y prime, we find that it's 1 over cosine of y, but we're not done yet. We want dy dx, or y prime, in terms of x, not in terms of y. We can rewrite this in terms of x using the equation we started with, x equals sine of y, where y is the angle of the triangle. Since sine is opposite over hypotenuse, these two sides are going to be x and 1, and the third side of the triangle can be found by the Pythagorean theorem to be the square root of 1 minus x squared. Cosine of this angle y is just the square root of 1 minus x squared. So y prime, or d dx of inverse sine of x, is just 1 over the square root of 1 minus x squared. If you're interested in deriving the other 5 inverse trig function derivatives, pause the video here and try it on your own using the same technique of drawing a triangle. If you derived correctly, here are the derivatives that you should have found. Notice that inverse sine and inverse cosine are negatives of each other, as are secant and cosecant, and tangent and cotangent, making it easier to remember or derive all 6. Knowing how to derive these is a really useful technique because that way you don't have to memorize them, and if you're on a test and you can't remember or you just want to check your answer, this is a really good method to use. Thanks for watching, and if you want to try some example problems to apply your knowledge of the inverse trig function derivatives, you can check out the link here or in the description below for this video.